Hello there again. My name is Sam Cheney and welcome to another installment of the Inspection Insights webinar series, where we are going to get real specific and learn tips, tricks and insights about everyone's favorite QC software, Geomagic Control-X. Now today what we have on the agenda, or really the part that we're going to be focusing on, is another consumer product. You might have seen this on our reverse engineering webinar series called the RE Lab. If you're not familiar with that, make sure you go check it out. And yeah, we did this a couple of weeks ago, and this is going to be a cosplay mask. Kind of reminds me of something out of Guardians of the Galaxy, or I'm not really sure, but it's pretty cool. We have scan data, which is going to be in blue, and then we have the model that was reverse engineered, which is actually yellow in this instance. Now, sometimes you might see these models as yellow or like gray, silver color, and that's an indication on if it's a solid body or a surface body. If it's a surface body, aka it has like one surface, then it's yellow. If it has surfaces on all, top, bottom, and all the sides, then it is a solid body, and it is denoted by the color, gray or silver. This mask is, like I said, pretty interesting, a lot of unique geometry. The actual scan, there's a lot of warpage in it, so it'll be pretty interesting to get into and analyze. For those of you unfamiliar with what a typical inspection workflow is going to look like, this is how it works in Control-X. So we have our input, our reference data, which is CAD. In this case, it's that yellow surface body that we created in DesignX. And then we have our scan data, which is the blue model, scan data. Anyway, it's a triangulated mesh, or it could be a point cloud. You can scan this with a variety of different equipment. For something, as small as a mask, probably a handheld or an ARM-based scanning system might be appropriate. But each to their own. We're not going to cover different differences between all the scanners. To learn more about that, you can head over to the RE Lab. Then we're going to align the models. Now again, I kind of talked a little bit last week about alignments, and I do plan in the future to do an entire series about just different kinds of alignments, but we're going to do our best fit alignment today, and then we're going to do our inspection. Finally, we will make a report, and then we have successfully inspected this model. And a little honorable mention to the different plans inside of Control-X. So we have three. There is the Essentials, which has all of the basics tools that you need to do, pretty much every kind of inspection, without getting too far in the weeds with scanning, like scanning directly into the software, or doing high volumes of inspections. So actually having the ability to do automatic inspections, running it kind of quote unquote headless, with an automation server, or some of the more advanced inspection and comparison tools. Essentials Connect it has all the power of Essentials, and now the ability to scan directly into the software, which is really useful for a lot of customers who are wanting to use Control-X to not only analyze and compare their data, but actually use it to bring scan data in, capture it, and clean it up. Finally, we have Control-X Professional, the one I recommend for most people, especially if they have a high volume of inspections. With this, you get all of the power of everything else in Control-X Essentials and Connect, but you get access to all of these really useful tools, which are especially useful if you have high volumes of inspections. You need to do inspection of multiple pieces at once, or you want to do you work in the aerospace or automotive industry and you need to use some of those specific surface defect or airfoil analysis tools. Now we are done with the presentation and into the fun stuff, where we're actually inside Control-X. Again, went through a bit of an overview of what this dialog, or what you're looking at on your screen, should look like. For any of you who are new to the Inspection Insights series, I'll give you a quick rundown. Control-X is based on a Parasolid CAD kernel, which means it looks and behaves and feels very much like creating a drawing or doing any kind of CAD analysis in SolidWorks, Inventor, whatever your favorite 3D model software is. At the top we have our tabs with different tools. So we've got the quick start toolbar, which we can use for anything from basic inspections all the way up to some pretty complicated stuff. Home, tools, dimension, live capture for actually connecting to and scanning into Control X, all the way into the report tools as well, which are over here. On the left hand side we have our results data, and this is going to essentially be like our feature tree. We've got all these buckets. When we add things like alignments, comparisons, etc., they are going to be populated in these different buckets. Down at the bottom is going to be where we see our screenshots, very important for when we make a nice pretty report. And then we have our properties display, and we actually have a table view down here which will populate if we actually added any linear, radial, etc., GD&T kind of dimensions. Now I'm not going to do really any dimensions today. My focus is going to be on the comparisons. So you can see we've got our CAD in, and we've also got our scan data, and you can see they're actually already aligned, because in our alignments tab over here we've done our initial alignment, always the first one we do. It basically just roughly positions the two objects together, and then we did a best fit. Now this best fit, if I double click into it, you can go back and edit it. You can see I left it at pretty much default. Because this model was either injection molded, vacuum formed, something like that, has quite a bit of warp. You can see you've got a pretty decent alignment on this side, but then there is some kind of asymmetry going on with the actual scan data, and that's to be expected, especially if it was vacuum formed. Things that undergo heat tend to at least warp a little bit, but again, we're happy with that. When we were reverse engineering this, obviously we're not going to model that asymmetry in unless it's really critical to the function, and then you kind of get into, well, why don't you just auto surface it? But anyway, we're getting off topic here. With our model, obviously this is idealized. This is the gold standard. We've got a nice symmetry between the two. The mask looks perfect, and obviously as soon as we bring it into the real world, we have some forced asymmetry and deviations. So if we wanted to, in our alignment, we don't have to necessarily just use all of this data to do our alignment. We can actually say, hey, use only selected data, and I could say, hey, I know this side is good, so maybe let's just use this side and we don't care about this other side, or vice versa. Maybe we want it to actually align closer to this side. Hit the check mark, and you can see if I overlay the two now, looks pretty similar, but now we are definitely using this data that we've selected as to influence our best fit. Okay, so we've got our alignment. I'm going to turn my measured data off because we're pretty much always going to do most of our work on the CAD. Then I'm going to do a 3D comparison, especially with these kind of organic shapes. Doing any kind of like actual dimensions is tough. While we can select, cylinder to cylinder and things like that, it doesn't really communicate how to fix problems or how to analyze it. So especially with organic geometry like this, the first thing I always do is a 3D comparison. Now I'm really going to geek out about the 3D comparison tool today because I think it's useful to go over. It's a really good refresher for anybody who isn't familiar with it. So in the 3D compare tool, we can decide what kind of comparison we want to make. Do we want to just look at the general shape, or do we want to measure the thickness of the part? Now, this CAD, although it's silver in this one, remember our presentation where it was yellow, this is actually a surface object, so we can't do thickness in this instance because we'd have to give it some thickness first. So we're not going to do thickness, but we can do shape, and then we have our desired projection direction. Now, shortest works for almost every application, but sometimes you'll want to give it a custom direction. Maybe you are only interested in the direction of draft or the direction of pull, and you can say, hey, constrain it to the x-axis. Or if you want to, you can flip it or give it, some other direction where you can give it, give it the coordinates, and then there you go, you're done. Now again, I'm going to leave it at shortest. And I think I mentioned this last week, but again, for anybody new, we also have the ability to change the resolution of the color map. Now, this is really useful if you're just trying to get a quick inspection done, easily, and you just want to kind of, before you dig into the data, you just want to see a quick result. We can slide it down to low, and it's going to just use, a low resolution mesh in the background. Now, if you slide this bar all the way up to high, then it's going to essentially, add more data points, more triangles to the scan data to give you a higher fidelity mesh to compare with. This is really useful if you have small, subtle features that are on the surface. I've seen this work really well with like logos that are like very lightly stamped or embossed on a surface, and you actually want to compare them, or very, very small features that you're just trying to eke out a little bit more resolution. Just another insight for you: the closer this higher bar, this resolution bar is to high, the slower or the longer it's going to take to generate the 3D compare result. So if you're just looking for a quick one, slide it onto low. If you want something a little bit more higher fidelity, slide it up to high, but use it in moderation because you want to balance performance versus output. So we hit our next icon and we're going to get our color map. Now you can see here it's looking pretty trippy, very tie-dye. We've got deviations in certain locations. Again, we know this side is always going to be a bit better than this side. We could just see it straight from the mesh, or straight from the alignment. Now, we have a color bar here, and it kind of goes from hot to cold. Now, what does that mean? Well, if I expand this over here, this is an article from the help that I thought was pretty useful. And I'm just going to dwell on it now for a couple of minutes. You can see here with the red through to orange and yellow, that indicates that the measured data is bigger or higher than the reference. So what does that mean? Basically means your scan data is sticking up from where it should be from the CAD. So you can see here you've got your measured data and your reference data. Reference data is CAD. Green is the ideal range. This can change. This is essentially your tolerance that you're willing to, the allowable deviations you want. And then blue is the measured data, aka the scan, the real world part, is lower than the CAD. So you've got essentially, think of it like a dent or convex. You've got like dents down here, and then you've got kind of bulges up here in the red zones. So that's just something to know to help you understand the color bar. Inside this color bar menu, we can see it as a color map. If we want to change it, we can change it to a whisker multiplier, and this is where we can change. Again, be careful with that whisker multiplier, but you can really have it exaggerate some of the deviations, and you can always reduce the number of them if you want it to look a little bit less furry. But I'm going to leave it as color map, but you can also do color points as well, each to their own. Again, I like color map, but just want to talk you through this whole menu. Okay, so then we have our color bar option, which is our maximum and minimum range, and then specified tolerance, which is the green zone that we decide here. You can edit all of this over here. You just move it up and it's symmetrical. You can force it to be asymmetrical if you'd like, or you can edit it over here. So if you just click over this and you drag it up, we can change that tolerance zone here. We can change this top one here as well. You can either drag it or you can actually key in a number, and it's up to you. There's a lot of different ways you can skin this cat. Over here, two different ways. Now, what if we don't want to actually see this the entire thing of the color map? We know there's deviations over here. We don't care about them. Honestly, we wish that it wasn't there. Well, we can go back, and instead of just doing a color map for the whole thing, just like our alignment, we can do use selected data only. So maybe I'm just concerned with this top surface here. Let's do that. Maybe let's do this surface as well. Give him some cool looking surfaces. Hit the next stage, and you can see we're going to get just the color map on those selected surfaces. So if you don't necessarily need the entire thing, well, you don't have to worry about it. You can use selected data. Okay, let's minimize some of these. We're going to go along this list. So we've adjusted our color bar. What again, if we don't necessarily care about, if it's up and down, we just need to know where's good, where's bad, with like a go, no go gauge. Well, if we use this select template, we're going to get the option to change our scale, change how our color bar looks. So, the standard one is this one, discrete. But if we don't care about higher and low, we can change it to symmetry. You can see there, it's going to just be essentially, blue through to yellow, and obviously our tolerance is on top. If we don't want that tolerance, we can turn it off as well. Now, we can also change it to a go, no go. So we can specify what's go, what's no go, and then there you go. We've got there you go. So many buttons. We've got the ability to check it out this way. Again, it all depends on what you want to display. I'm not an expert on your application, but I'm just talking you through these options and giving you my thoughts on them. We also have the ability to do signed, so make it a little bit less discrete. Just have a few simpler colors. Make it really clear where those deviations are. Again, for 90% of applications, I'm probably going to do discrete. If anything, I might do a go, no go as well. Okay, so that's kind of some of the color bars. Again, you can edit it until the cows come home to make it whatever color you'd like, or make it match whatever is on your drawing or your standard tolerances. And then we move on to our tagging. Now, not like spray painting a train or anything like that, but like actually adding deviations. So, we talked about this last week. We can add deviations. If we want to move these deviations, they're kind of fixed right now, right? If you ever, they do move a little bit when you rotate it around, but you can't drag them over anywhere. That's because you can control them up here. If you set it to automatic, it's going to move itself. And if you change it to this one, snapped, it gives you the ability to click and drag these annotations. Regardless of if you have it set to automatic or snapped, you can right click, change the preset of them to whatever you'd like. You can even come in and make your own presets if there's something specific that you'd like to show. I like to leave it on basic or default, just my personal preference, but you can change to whatever you would like. What if we don't want any of these? So if I just hit undo, oops, if I hit the check mark, if I want to remove these, I can come down and just select them, delete them, accept, there we go. All right, what if I want the annotations to look a little bit more neater, right? Maybe me just clicking around isn't gonna cut the mustard. Well, if we minimize this so we can really see the rest of this menu, the local average tagging, we can set up patterns of points. So if I wanted to I really cared about this ridge line here, I can select a long curve, and then I'm going to give it a seed position, so I can give it a position up at this top, and then you can see here I can specify here, we can say, hey, we want more than one, we want 7 spaced every 10 millimeters. If we want to flip the direction, we can, but we're going to have it equal spacing along this curve. And then all I have to do is hit the check mark. Yes, I want to apply the preview tag, and there you go. We've added these. Now this really looks better when you have the automatic tags turned on. The same way, I'm going to keep them, but I'm going to turn it off for now. The same way we had a longer curve, we can actually do local average tagging. We could do a linear pattern, or circular pattern, spherical pattern, whatever you want. Again, do I use this super often in my day-to-day usage of Control-X? No, I'm pretty slap happy when it comes to just, I know roughly where I want them, so I'll specifically tag them in areas that I want. But But if you're trying to, if maybe you're doing an inspection again and again and again, and you want to set up a nice linear pattern so you're always going to be taking deviations at the exact same point, you can do that pretty easily. This automatic tagging over here shows the maximum and minimum high and low, right? So you have the worst deviation right here is 2.38, I think that's millimeters, and then under tolerance, which is that blue area, it's going to be over here. And obviously we've only got one, but if we want to increase that, the more we do is going to pick, the next worst area and just keep going down that list. And you can do that for both higher and lower. Now I don't actually want the under, but I think the over looks pretty nice. So again, I can hit this check mark, and there we go. We've got a really nice annotated color map of just selected surfaces. And you can see here, if I click on this, it's going to show me my preview. Now, this looks okay, but I actually want another view over here. And if I change this, there we go. Here, rather than reassign, I'm going to hit add viewpoint. So we're going to add another custom view. You can see here, custom view, a little bit small. So just zoom in, reassign. There we go. All right, lovely. Okay, so that's 3D compare in a lot of detail. And if you ever want to learn more about the 3D comparison tool, or really any tool, you know how I pulled that help article up earlier? Well, if you press the F1 key on your keyboards, it's going to open up a contextualized help menu. So you can see here we're in the 3D compare tab, and we have the 3D compare help specifically pulled up. And these are pretty decent articles. You should definitely read them if you're ever stuck or just curious about how a particular tool works. It changes as well. So if I go from 3D compare to 2D compare and I press the F1 tool again, we get the help for the 2D compare. So we have a help article for every single tool in Control-X that you can use. And again, they're all pretty well written and go through all of these different menus or sub-menus that you can select and really learn something from. If you want to, maybe if you haven't found the result or the help that you're looking for, you can also go to this index in the help tab and just search. Maybe I want to learn more about cross sections. So I type in cross, and you can see there we've got the help article for cross sections. Double click, and there we go. We've got the help that we need. So there's a lot of, although you can obviously reach out to support, but there's a lot of help available to you at your fingertips. The last little insight that I want to give you is, in the help, we also have a menu help. Not only can you do the contextual help, you can look up release notes, you can find your license information, submit a support ticket, but what I really want to focus on today is the tutorial. Now these are, I really, really like them. Definitely useful for any new users. If you've got a summer intern that you're trying to train up really quickly, this is definitely a really good start for them. Even if you're not a summer intern, you're just learning the software for the first time. Basic courses, you walk through some basic stuff. You do some scan to scan. You learn about sheet metal inspections, and then we can go back. And here we go. Help. Tutorial again. You can see we've got some advanced courses as well. Inspection with PMI, scan to scan inspection, which is definitely something that we'll have to cover in a later one. A whole tutorial on reporting, and you hit next, and you can see here, it gives you step-by-step guides. Now, if I edit report layout, you can see there, it gives you a step-by-step on how to edit everything. In certain ones, when you're working inside Control-X, with this one you're working inside the report editor. Here, let me show you rather than just tell you. Tutorial, basic courses, inspection with GD&T, using datum alignment. You can actually have it highlight the command. You can see there, it's going to put a red box around the alignment. You can even have it run the command straight from the tutorial window. So again, lots of help at your fingertips. And if we're at this point in the conversation. We've got a comparison that we're happy with. We just hit generate report and generate our report. But really today, what I wanted to focus on is the 3D comparison tool and inspecting these kind of consumer product focus where we've got deviations and adding in dimensions doesn't quite cut it. We really want to look at a color map. So hopefully you learned something. Let us know if you want to cover a specific topic or anything like that. And yeah, I'll catch you on the next one.